Hello everyone, welcome back to the channel. We know that silicon rules power electronics for more than 50 years. But today, two new technologies are changing everything. Silicon carbide known as SiC and gallium nitride called as GaN. These devices are making EVs charge faster, power supply smaller and renewable energy more efficient. But the big question is which one is the future of electronics, SiC or GaN? In this video, we'll compare them deeply from physics to real world application. By the end, you will clearly know where each technology wins. For decades, silicon devices like MOSFET and IGBT dominated power electronics. But modern system demanded higher efficiency, smaller size, higher switching frequency, less heat generation, and silicon is starting to struggle because high switching losses, limited temperature capability, larger cooling requirements. That's why engineers started moving towards wide bandgap semiconductors. Wide bandgap material have higher energy gap compared to silicon. This gives major advantages: higher voltage handling, faster switching, higher temperature operation, lower losses. The two stars today are silicon carbide SiC and gallium nitride GaN. Now let's understand each one. Let's understand silicon carbide. Silicon carbide is designed for high power and high voltage applications. So the key advantage of silicon carbide is high voltage capability up to several kilovolts, excellent thermal conductivity, then lower conduction losses, high reliability in harsh environment. That's why SiC is widely used in electric vehicle inverters, then fast charging stations, solar inverters, then industrial motor drives. So we can say that SiC high power, high voltage, and high duty applications we can use SiC. Okay, let's talk about gallium nitride. So gallium nitride focus on something different. So that is speed. The GaN devices switch extremely fast, which means smaller magnetic components, smaller transformers, higher efficiency at high frequency, then very compact design. You already use GN without realizing it in the first phone chargers, laptop adapters, then data center power supplies, then consumer electronics. So in simple words, we can say GN is for the high frequency, compact and lightweight designs. Okay, now let's compare them directly. So if we need voltage capability, so we'll use SiC, excellent for high voltage systems. GN best for low to medium voltages. Now, if we need higher switching speed, in that case, GN switches faster. SiC is fast but slightly slower. Then thermal performance, SiC handles heat better. GN needs careful thermal design. Then in case of that efficiency, both are highly efficient. GaN excels at high frequency, SiC excels at high power. In terms of cost, GaN currently cheaper for low power, SiC more expensive but growing fast. Let's see where industry is actually using them. In electric vehicles, SiC dominates EV inverters and the high power converters. Then the higher efficiency increases driving range. For the fast chargers, both use depending on power levels. And high power chargers, then SiC is used. For compact adapters, GaN is used. Now in the renewable energy like solar and the grid system prefer SiC due to the voltage capability. In consumer electronics, GaN is replacing silicon chargers. The future isn't about one winning completely. Instead, SiC will dominate high power industries, then GN will dominate compact high frequency electronics. So future system may even combine both the technologies together. Engineers call this the hybrid power electronics era. So now you know SiC and GN are not competitors. They are partners shaping the future of power electronics. Which one do you think will dominate in the next 10 years? Comment below. If you found this video useful, don't forget to like, share and subscribe for more electrical contents.